All right, this is the last part of the first week of lessons, and we're going to do a little bit more of slope here. So what we would like to do is now talk about parallel and perpendicular lines. Okay, so for parallel lines, we are talking about two lines that will never intersect. And the thing that we're going to use is that they have the same slope. So if I have two parallel lines and say the slope of the first is 2, then the slope of the second line is also 2, okay? They are going to have two different y-intercepts, right? If they have the same y-intercept, then they are actually the same line, right? They overlap completely. And the symbol that we use for parallel lines, usually we draw this vertically, but I'm assuming that in some cases that might be mistaken for numbers or something else, so we're going to put them on a slight angle. Right? It's just two lines that run parallel to one another. Perpendicular lines, right? The term perpendicular means that two lines that have a 90-degree angle between them or that intersect at a 90-degree angle. Okay. They have what's called opposite reciprocal slopes. So if the slope of the first line is, let's say, 2, then the slope of the second is going to be opposite, meaning opposite in sign. So it becomes negative. And it's the reciprocal, meaning you flip over the fraction, right? If you would like to think of this as 2 over 1, it becomes minus 1/2. Okay. And the symbol that we use for perpendicular lines looks like this. And that's just to denote, right, that they intersect at 90 degrees. Okay. So what we would like to do here is we would like to be given a slope and a point to find lines that are parallel to the previous or find lines that are perpendicular to. Okay. So here in the pictures, right, these just depict what we were just saying, right? The first set is parallel. Notice they have the same slope. They have different y-intercepts, which graphically, right, are here and here. And then the perpendicular lines, notice that their slopes are opposite reciprocals. They intersect at 90 degrees as well. Okay, so see if we can complete this table here. So we have a slope given. We would like to know what would be the slope of a line parallel to each one of these and then perpendicular. Well, the parallel's pretty easy, right? Remember that the slopes of parallel lines are the same. So for each one of these, it's the exact same value. For perpendicular lines, they are opposite reciprocals, okay? Which means if it's a fraction, I flip it over and I change the sign. So instead of negative, I now have positive, and instead of 2/7, I now have 7/2. And then we don't really need that plus there, right? It's understood. All right, this one is 5 over 1, if you'd rather write it that way. So when I take the reciprocal, it's 1/5. And then I need the opposite, which makes it negative. This last one is probably the hardest one. Right, this is technically 0 over any number. Let's say 0 over 1. If I were to flip that over, right, to get the reciprocal, I get 1 divided by 0. I would technically take the opposite, which would make it negative. But what does 1 divided by 0 represent? Well, that is undefined. And let's think about that for just a second. So what kind of a line has a slope m equals 0? Okay, let's go back to what does slope mean? Well, that's rise over run. If it equals 0, that means there's 0 rise and it can have any value for the run. 0 rise means that we're not moving in the y direction. We're not changing. So that would be a line that looks like what? Well, if y isn't changing, then it's got to be a straight line, right? And it's got to be horizontal. What does an undefined slope look like? Well, that says there's no run, which means x is not changing, which means I get a vertical line. A horizontal line and a vertical line are in fact perpendicular, okay?